So now we want to study type of intermolecular forces. Before that, what is intermolecular forces? You see here, inter. We got intra also. Okay, now what is the meaning of intermolecular forces? IMF, the short form is IMF. Attractive forces, okay, so attractive forces between molecules. This one we call as inter. Inter means should have between the molecules. Attractive forces between the molecules. For example, X, Y. So this is the molecule. So X, Y. So you must have two molecules. So the attractive forces between these two molecules we call as intermolecular forces. Okay, between. After that, its strength determine the physical properties of the substance. That means physical properties means, for example, melting point, okay, melting point, boiling point, okay. After that, solubility. So these physical properties will be determined by the intermolecular forces. How strong or how weak the intermolecular forces will give effect to the melting point, boiling point, or solubility. How many types of intermolecular forces? We got two: hydrogen bonding and van der Waals forces. Hydrogen bonding and van der Waals forces. Okay, so now let us study one by one. Which intermolecular forces are the strongest? And which intermolecular forces is weakest? Okay, so you're going to see in this section. Van der Waals forces, I already explained to you the meaning. Attractive forces between molecules, between neutral molecules. That means does not have any charge. Neutral means does not have any charge. Type, okay, now we are in van der Waals forces. Van der Waals forces got two. One is dipole forces, another one London dispersion forces. Dipole, just now we already studied, we got dipole positive and we got dipole negative. So between this dipole, we got force. Okay, that one we call as dipole forces. After that, we got another force we call as London dispersion forces. These two is under van der Waals forces. Okay, which forces is the strongest? Hydrogen bonding is the strongest. Which forces is the weakest? Van der Waals forces. Okay, this one is van der Waals forces. So between van der Waals forces and hydrogen bonding, which one is stronger? Hydrogen bonding. Which one is the weakest? The weakest is London dispersion forces. Weakest. Okay, dipole forces in the middle. So if they ask you which forces is the weakest forces, so the answer is London dispersion forces. Which intermolecular forces is the strongest forces? hydrogen bonding. Okay, now let us study dipole-dipole forces. Dipole-dipole forces. Before that, you have to remember what is dipole-dipole. We got dipole positive, we got dipole negative. The forces arise from the attraction of permanently positive and negative end of a neutral. Neutral means does not have any charge. Polar molecule, you see here, must be a polar molecule. It's not a non-polar molecule, must be a polar molecule. Okay, let us see one example here. I got HX, sorry, I got HCl. Okay, is it got permanent positive and negative end? Let us check. Let us check. Okay, so hydrogen and chlorine, two different electronegativity atom. So this one is more electronegative atom. This one is less electronegative atom. So I can draw the bond dipole. So I can draw the bond arrow, polar arrow. So this bond is polar bond. Okay, this bond is polar bond. This bond is polar bond. How about this molecule? Is it polar molecule? Yes. So let me see. Is it all the condition already fulfilled? Polar molecule? Yes. Is it got permanent positive and negative end? Okay, let me see. Got dipole positive and dipole negative. Okay. But dipole-dipole forces is not occur yet. What is the meaning of intermolecular forces? Between two molecules. So now only I got one molecule. So I need another HCl molecule. Okay, I need another HCl molecule. Okay, and just now we already studied. This one is a polar bond. Okay, and this molecule is polar molecule. Okay, we already studied just now. Okay, now where is the dipole-dipole forces? Where is the dipole-dipole forces? The dipole-dipole forces arise from the attract each other. Which one will attract? Permanently positive and negative end. So negative end is here, positive end is here. So here will be the forces. So this force we call as dipole-dipole forces. Okay, dipole-dipole forces. If got another molecule beside this HCl, okay, let's say I got another molecule here, HCl. Okay, got a dipole positive and dipole negative. So here will be delta positive, here will be delta negative. This is polar bond. So this molecule is a polar molecule. So where is the dipole-dipole forces? Where? Forces arise from the attraction of the permanently positive and negative end. Where is positive and negative end? Here I got negative end, here I got positive end. So here will be the dipole-dipole forces. Okay, can you follow what is the meaning of dipole-dipole force? Okay, how to measure the strength of dipole-dipole forces? How I know that dipole forces is very strong? Depend to the molecule. If more polar molecule will have a large dipole moment. So the dipole forces will be very strong. If the dipole forces is very strong, more energy is needed to overcome the strong dipole forces. So finally, the boiling point will be increases. Okay. Now, for example, I got HF. I got HCl. Okay, after that, between another HF, okay, is it confirmed? Here will be delta positive, delta negative. Here will be delta positive, delta negative. So, sorry, FH. Okay, so where will be the dipole forces here? Okay, so here is the dipole forces. Here also same. Okay, here also same. I got HCl. Got two molecule here. Two molecules. Okay. So delta positive, delta negative, delta positive, delta negative. So where is the dipole forces? Here. So here will be the dipole forces. Now my question, which molecule got higher boiling point? Which molecule got higher boiling point? HF or HCl? So you have to know. He also got dipole forces. He also got dipole forces. But which dipole forces stronger? Which one is stronger? In HF, sorry, between HF or between Cl? You have to answer this question. Which one is more polar molecule? F and Cl. Which atom is more electronegative? Which atom is more electronegative? Is it both in same group? Anyone? Is it F and Cl in the same group? Is it F and Cl in the same group? D2, T7? Can you hear me?
Yes, sir.
Can you hear me?
Yes, sir.
Okay. So can you follow my question?
Yes, sir.
Is it F and Cl in the same group?
Yes.
Yes.
Yes, okay. So let us arrange. Let us arrange. Um, F here, Cl here. Group 17. True or not? Okay, now down the group. Down the group. How is the electronegativity? Which atom got higher electronegativity? Fluorine or chlorine? You have to see the size. Which one is smaller in size? F or Cl? Which one smaller in size? F or Cl?
F.
F. F is smaller than fluorine. So which one got higher tendency to attract electron towards itself? Which one, the distant nucleus and the outer electron very close?
F.
Fluorine. So fluorine got higher electronegativity than Cl. If got higher electronegativity, so the molecule will be more polar molecule. So if the molecule is more polar, the dipole-dipole forces also will be stronger, very strong. If very strong, is it easily we can break this dipole-dipole forces? Is it easily we can break? No. You require more energy to overcome the strong dipole-dipole forces. So boiling point will increases. So HF will have higher boiling point than HCl. That is the conclusion. The more polar the molecules, the stronger the dipole-dipole forces, higher the boiling point. Now we want to discuss London dispersion forces. An atom has protons in its nucleus and electrons surrounding the nucleus. So this is the basic fundamental structure of the atom. I think everyone already knew about it. In the nucleus, we got proton and neutron and the electrons surrounding the nucleus. So now you can see. Here I got one atom. What is the negative here? Electron is moving. Same. This is another atom. The electron is moving. On average, the negative charge of the atom is spread evenly around the nucleus. So you can see the electron charge is spread evenly around the nucleus. Okay. How want to have a force? Because negative and negative, how want to attract? Cannot. Same force, same charge, how want to attract? Okay, so here no any force here because same charge, electron is moving. So how to get a dipole? I want to get a positive and negative dipole so that can have a force. How? Okay, at any instant, that means at any time, one side of the molecule has higher electron density than the other side. Okay, just now I already informed to you the electron is moving. Here also the electron is moving. So the electron is moving. So when electron is moving, what happened? The electron can go up, can go down, can go left, can go right, anywhere. True or not? Because the electron is moving. So at one time, when the electron is moving, at one time, all the negative at one side, like this. When the electron is moving, at one time, we don't know when. That's why they said at any instant. At any instant means at any time. At any time. No any specific time. At any time, one side suddenly got more negative charge here. That means this area rich with electron. Okay, that time, the atoms or molecules become a small instantaneous temporary, you see, temporary dipole. So if got more electron, what is the dipole? We can use dipole negative because electron density is higher. This area, electron density is less. So here will be dipole positive. Now you see, we already got a temporary dipole. I already got a temporary dipole. Small Small instantaneous means at any time, a very little or very short temporary dipole, very short, in a very short period of time, suddenly appear, delta negative and delta positive, because the electron is moving. Okay, now is he already got a dipole negative and dipole positive? Okay, this one for one atom. How about if beside here got another atom? Okay, this one what I explained to you. At instantaneous got a temporary dipole is formed. Okay, beside here got another atom. Okay, another atom, same case. Suddenly instantaneous temporary dipole is formed. So the temporary dipole can induce a similar dipole on a neighboring, okay, neighboring atom. So which one is neighboring? For this atom, which one is neighboring atom? This one. For this atom, which one is neighboring atom? This one. Okay, now I think you already know what is the meaning of neighboring atom. Temporary dipole. Which one is temporary dipole? This one. This one we call as temporary dipole. Okay. After that, induce a similar dipole to attract one another. So they will try to attract one another. So dipole positive will attract the dipole negative. That one we call as induce. Okay, so this force between these two, temporary dipole and an induced dipole, we call as London dispersion forces. And this one is temporary, not permanent. Okay, not permanent. Why? Because the electron can start to move around. When start to move around, the electron density will change. So the dipole, position of the dipole will change. So that's why London dispersion forces is the weakest forces. Why is the weakest forces? Because just form temporary at any instantaneous temporary dipole. Already know should have hydrogen. Okay. Special type of dipole-dipole interaction between hydrogen atom in a polar bond, must have a polar bond, such as NH, OH, FH, and the negatively charged electronegative atom. So must have fluorine, oxygen, nitrogen bonded with hydrogen. Okay, so hydrogen bond are stronger than van der Waals forces, but weaker than covalent bond. And now let us see how hydrogen bond can form. How hydrogen bond can form. Hydrogen bond between HF and water. Okay, between molecules. So I got HF And we already studied, is it this bond is polar bond? Yes, polar bond. So got a dipole positive and dipole negative. Atom fluorine is more electronegative than hydrogen. Okay, and I got water here. Is it this bond is polar bond? Yes, polar bond. Hydrogen and oxygen, this bond is polar bond. Oxygen is more electronegative, hydrogen is less electronegative. Oxygen is dipole negative, hydrogen is dipole positive. Okay, so there will be a force. Sorry, there will be a bonding between F and H. Must have hydrogen and F. You see? So this one we call as hydrogen bonding. Okay, hydrogen bonding between the atom more electronegative F, O, or nitrogen. So here the example is using fluorine. Okay, now let us see another example. Between hydrogen bond between ammonia and water. So this is ammonia. So where is the dipole? So here will be the dipole positive, dipole negative, dipole positive, dipole positive. Is it this bond is polar bond? This bond is polar bond, yes. Okay, now water. Okay, I got water. And just now we already studied. This one is delta positive, delta positive, delta negative. And this bond is polar bond. Okay, all the requirement is there. So between H and O, this one we call as hydrogen bond. Okay, between H and O. Okay, another example. Another example. Hydrogen bond between ammonia and HF. Okay, this is HF. Is it this bond is polar bond? Yes, so this is dipole negative. Here will be dipole positive. Here I got an ammonia. So this is dipole positive, dipole positive, dipole positive, dipole negative, dipole positive. So between F and H, okay, this bond we call as hydrogen bond. H with N.